Now we'll look at transformation of functions.
Vertical shifts, we want to recall that the y-axis is the vertical axis, which means it goes up and down. Thus, when we add or subtract a constant from y, like the entire function f of x plus or minus some constant k, we will be shifting the entire graph up or down. That's why it's called the vertical shift. Now, vertical shifts work the way that we think that they would. If we're adding, we move up, and subtracting, we move down. Let's consider the function f of x equals the square root of x. If we subtract a 4 from the entire equation like this, the entire graph will end up shifting down 4 units. If we were to graph the original square root of x, the square root of 0 is 0, square root of 1 is 1, and I'm going to go all the way out to 4. The square root of 4 is 2. So that is our original function, where f of x equals the square root of x. So when we subtract 4, that means we're taking every output value, because you're subtracting that 4 from the square root of x. We take every output value and we subtract 4. So with this first point, our y value is 0. So now our y value is -4. When x is 1, our y value was originally 1. When we subtract 4, we get 3. And when our y value was 2, we subtract 4, we get down to -2. So notice the shape stays the same. It is just that the entire graph moves down 4 units. Horizontal shifts are similar. Recall that the x-axis is also called the horizontal axis. It goes left to right. So when we add or subtract a constant from x, like f of x plus or minus some value h, notice that is an inside change, inside a parentheses somewhere with x, we will be shifting the graph left or right, called a horizontal shift. Unfortunately, horizontal shifts do not work the way that we think that they would. When we add, instead, we move left. And when we subtract, we move right. So one of the ways that helps me to remember it is thinking of solving like a quadratic equation where it's set equal to 0. There's that inside binomial x minus 3, but when we set it equal to 0, we end up actually adding 3 to both sides. So our solutions are opposite of what we see. So anytime you have that inside change, think of the opposite. So again, we want to consider the function square root of x. This time we're adding 3 to the input value. So notice how that 3 is inside that grouping symbol of a radical. It's not afterwards like when we added the 4, subtracted the 4. It is inside the radical. So that means the entire graph will end up shifting left 3 units. So again, our original, we had 0, 0, 1, 1, and 2, 4 equals the square root of x. And now we'll shift everything to the left 3 units. And this is the new function where we've taken the square root of x plus 3. So what I like to call an inside change will shift it left or right. An outside change will shift it up or down.